Hello students, very good morning, good afternoon, good evening, one and all present here. I am S.K. Tripathi, PGT Math of KVS, want to share my teaching experience. And the most important part of the mathematics is trigonometric functions of class 11 and inverse trigonometric function of class 12, and connecting both of them the graph and the shortcut tricks on principal range of inverse trigonometric function. Before starting the trigonometric function graphs, as you know, the basic concept underlying the domain and range, and I'm just doing some graphs recalling the what we have done in class 11. Let's say this one in when y is equal to sin x. When y is equal to sin x, and the graph from unit circle diagram of the NCERT book, that its period is 2 pi. This is the shape of the sin x, and this shape is continued. And what we observe, if you draw a line parallel to x-axis, it intersects in this portion, and what we are getting here, sin pi by 6 is equal to 1 by 2, and also sin 5 pi by 6, this is pi by 6 and this is 5 pi by 6. It is also 1 by 2, it is many one function. And for inverse function, the function must be 1, 1 and on 2. And this shows that the trigonometric functions are many one functions. And to make the many one function into 1, 1 function, the domain is restricted. We have to restrict the domain. And coming to sin x, the domain is R and the range is -1 to +1. This domain, we restrict the domain and we make it minus pi by 2 to plus pi by 2 closed interval. Also we can make it pi by 2 to 3 pi by 2 and minus 3 pi by 2 to minus pi by 2. And these are all the restricted domain where the function sin x can be 1, 1 and 2, but we choose this one, and this is called the principal range. Now coming to, this is the sin x curve and the range. When you choose, if AB is a point, if AB is a point belongs to sin x, then BA, the corresponding point, belongs to sin inverse x. Never confuse, it is not equal to 1 by sin x. And the graph of sin inverse x, the most important part is that the graph of sin inverse x is obtained from sin x by interchanging x and y axis. Let us see this one. I am coming to this now. I have interchanged, and this is +1 and this is -1. I have interchanged the x-axis and y-axis. This is the graph of y is equal to sin x, and this is the graph of y is equal to sin inverse x. and here the domain is sine is r2 -1 to 1 and sine inverse is -1 to 1 to minus pi by 2 to plus pi by 2. This is of sin x and this is of minus sine inverse x. Now coming to cos x, and you know the cos x graph. Cos 0 is 1, cos 0 is 1 and cos pi by 2 0, cos 3 pi by 2 is 0 and cos pi is -1 and 2 pi. This is the graph of cos x and the domain. The domain of trigonometric function or any function, the domain of a function is a set which may be subset of the x-axis. What is x-axis? A set of real number. A set minus infinity to plus infinity. So the domain always lies on x-axis. And what we find the domain is cos r2 -1 to plus 1. And the inverse interchanging x and y axis. Here cos inverse just interchange from to interchanging x and y axis. So we have got this cos x and cos inverse x. Now coming to tan x. Number 3, y is equal to tan x and tan x is equal to sin x by cos x. So the domain it is r minus 2n plus 1 pi by 2. This will be the points excluded and tan has from to r. Now what you find here, tan at odd multiple of pi by 2 is not defined. So when we draw the graph of tan x, we draw separate lines which is perpendicular to x-axis, and this is very important that we have studied in class 11 concepts. This is the graph of tan x. This line never touches because at that point the tan is not defined, and this is a tan x, graph of tan x. But the domain is the entire set of real number x-axis. Now coming to tan inverse x. So this is just interchanging and x-axis and y-axis. So tan inverse x, that is the entire set of real number, to minus pi by 2 to plus pi by 2 open interval. Remember this point, because closed interval the points is included and the function is not defined. So coming to tan x, we are coming to cot x. and cot x is equal to cos x by sin x, and the domain of this function r minus n pi, because sin x is 0 at integral points and range is the set of real number, and cot 0 is not defined, so it's asymptote, and cot pi is also not defined, and cot pi by 2 is 0. So this is of cot x, and coming to cot inverse x, interchanging an x and y axis. Interchanging an x and y axis, so 0 and pi asymptote, and cot inverse, that is r to 0 to pi open interval. Now coming to sec inverse x and cosec inverse x. First of all, in cosec inverse x, we draw sin inverse x and at this point this part is called both the parts. What you find here, y is less than equal to minus 1 and y is greater than equal to 1, and cosec inverse range from minus pi by 2 to minus pi by 2 to pi by 2, so that r is very important. And coming to sec inverse x, we draw the curve of then actually we are not using this, we are using this graph for drawing this one. It will not touch this part, and this part is equal to, that is here y is equal to sec inverse, y is less than equal to minus 1 and y is greater than equal to 1, and sec inverse 0 to sec inverse 0 to pi minus pi by 2 that is to r minus minus 1 and cosec inverse x, cosec inverse that is minus pi by 2 to plus pi by 2, 0 is excluded, to r minus minus 1. Now we have seen the graphs of trigonometric functions and inverse trigonometric functions side by side. Now I am going to write down how to remember in a shortcut way and to use it. Now shortcut tricks for principal range of inverse trigonometric function. Now dear student, please look at here. Very important thing is that I have divided the plane into 4 parts called as quadrants, and the first quadrant all 6 inverse trigonometric functions exist for x greater than or equal to 0. I will deal with the problems now. And second quadrant, the only cos inverse x, sec inverse x, cot inverse x for x less than 0. And the fourth quadrant in anticlockwise sense, it is sin inverse x, tan inverse x, cosec inverse x for x less than 0. This is you have to remember. And third quadrant, no ITF exists. And if any sum comes under this category, we convert to respective principal range by ASTC rule. Now here is the problem. Now please watch this one. Here is the shortcut tricks. Repeating again. First quadrant, all 6 inverse trigonometric functions for x greater than or equal to 0. And second quadrant, cos inverse, sec inverse, cot inverse x less than 0. And fourth quadrant, sin inverse, tan inverse, cosec inverse for x less than 0. Now the problem. Now before going to the exercise, certain concepts that we have done here. Let us see this one. F inverse, what does it mean? From first chapter we have studied, and that is F inverse f of x, that is if f is a function from x to y, then f of x is equal to y and f inverse y is equal to x. Now what you find here, f inverse of f of x, f inverse fx, and fx is equal to y, so f inverse y is equal to x. Now a very important things I am going to discuss, that is f of f inverse x, that is equal to f of f inverse x, that is equal to y, and f of y is equal to x. So what happens? The composition of the function inverse and its, we are getting x. So now I am summarizing this to what you have now done in inverse unity functions. Now this one, now sine inverse x is equal to x if x belongs to -1 to 1, and sine inverse sine x is equal to x also, and x belongs to -π/2 to +π/2. So like this, now this part is very important, and we have to remember from the graph. Like this, the cot, cosec and sec. Now coming to the problem. If you will come to the NCERT problem, for NCERT, now sine inverse, question number 1 of exercise, sine inverse minus 1/2 is equal to how much? Now this x is the negative and it is in the fourth quadrant, and it becomes negative means -π/6. In other way you can prove it. Sine inverse minus 1/2 is equal to theta, then minus 1/2 is equal to sine theta, then minus sine π/6, and this comes of sine minus π/6. So sine theta is equal to sine π/-6, so theta is equal to minus π/6, that belongs to minus π/2 to plus π/2. So these are the steps that we have to do. Besides that, we can do by shortcut techniques. This comes to the fourth quadrant, and fourth quadrant, if it is positive, it is π/c, and fourth quadrant it is minus π/6. Now coming to question number 5. Cos inverse minus 1/2. So it is negative. Negative means second quadrant, and cos inverse negative. So let us it will be 2π/3. Now let theta, then minus 1/2 is equal to cos theta, and this is minus cos π/3, and cos is negative in second quadrant. Second quadrant is in principal range, that is cos pi minus π/3, and that is equal to cos 2π/3. So 2π/3, cos theta is equal to 2π/3, so theta is equal to 2π/3, and that's all today's video, and hope you have enjoyed. And in the next video I'll go for the ITF second part, exercises, properties, and previous year questions of JEE. Thank you.